Okay, we're going to discuss outliers. So outliers are points that are far away from the median of a data point. So students at Waldo High School are involved in a special project that involves communicating with people in Kenya. Consider the box plot of the ages of 200 randomly selected people from Kenya. So we can see the ages here. We can look at the lowest value, which would be there. We can look at the box and look at the different values, Q1, median, Q3, and then we can look at the highest value here, and then we have our outliers. Okay, so the outliers are points that are not within normal set of data. They're further removed from the data, so we represent them by asterisks. These are for people that live beyond the expected age in Kenya. So the data distribution may contain extreme data points. A box plot can be used to display extreme data, and they're identified as outliers. Each asterisk in the box plot represents the age of 4 people from the sample. Based on the sample, these 4 were considered outliers. So we want to find the value of those 4 points, it says. So if I look down, I kind of measured down and approximated that they were 72, 76, 82, and 100. So those are the values, approximate values of those outliers. So those are the ages of 4 people that lived beyond the average ages. An outlier is defined to be any value that's more than 1.5 IQR times the IQR away from the nearest quartile. So the nearest quartile is Q1 or Q3. So this is asking us to find the median age. So if we go to the box plot, remember the middle of the box is the median, so I estimate to 18. The Q1 is the low end of the box, which I estimate at 9, and Q3 is the high end of the box, which I estimate at 31. The IQR is the length of the box, so 31 minus 9. How long is that box in units? And it's 22. Okay, so now to find the outliers, we're going to take 22, which is the IQR, times 1.5. And if we calculate 22 times 1.5, we get 33. Okay, so multiply the IQR by 1.5, we get 33. So if we continue on the next page, it's going to walk us through this process. So we're going to add that number to the third quartile age, which we had just said on the other side, Q1 is 30, or Q3 is 31. So we add that and we get 64. So any number, any age greater than 64 is considered an outlier. And it says, what do you notice about the 4 ages identified as asterisks? 72, 76, 82, and 100 are all greater than 64. Are there any values that are less than the value? So if we want to find the less than values of the outlier, we take the Q1, which is 9, and we minus the IQR times 1.5, which we said was 33, and we get negative 24. And is it possible for are there any ages that are negative 24 or less? Because we want to be less than negative 24. And it doesn't really make sense in this considered case because we can't have ages that are negatives. Okay? If there were, then they would be outliers. So there's no asterisks on the low side because there cannot be any negative ages. So we cannot have negative ages. So if we have to be less than negative 24, then we can't have a value for an age that's less than a negative number.